Okay, having a look at question 20 from the tech-free paper of 2021 for maths methods. So we've got the population of rabbits. We've been given an equation for that when t is greater than 0 and t is the time in years. We want to determine the intervals of time when the population is increasing and the intervals when it's decreasing. So obviously it's a tech-free question, we can't just graph it. So the first thing we can do is find any stationary points, or what the, if you look at the marking scheme, they're called critical points. We refer to them as stationary points usually when I teach my class. So looking for a stationary point, we know is when the derivative is equal to 0. So first step, finding the derivative, so p dash of this equation. Now we've got t squared ln 3t plus 6. Now because it is a t squared in front of there, we can't just disregard that, which is quite a common error there. We actually have to use the product rule. So we can't just treat them individually. We need to treat that as a product rule question. So we have got u and v there, where u is equal to t squared and v is equal to ln of 3t. Now our u dash is then going to be 2t. Our v dash is going to be 1 on t. So now we're going to put that together. So our p dash is going to be u dash v plus v dash u. So we have got 2t plus ln of 3t, times. And then we're adding to that our v dash, so 1 on t being multiplied by t squared. So we get our 2t ln 3t when we put that together, and then that will become t on the end there. So that gives us our derivative. We can now then find when that's equal to 0. So we can write 0 is equal to 2t ln 3t plus t. So we can then factorize that. So we will get t outside of 2 ln 3t plus 1. Now that we've factorized that, we can use our null factor law. So either t is equal to 0 or the 2 ln 3t plus 1 is equal to 0. We can't have the t equaling 0 though, because we were told up here that our t was greater than 0. So we can't have that. T has to be greater than 0. So we're focusing on this one over here and we're solving it. So first step, taking the 1 over 2 ln 3. Then we can divide by 2, so we get negative a half is ln 3. Now we can do our rearrangement, and we know that e to the negative half would be equal to 3, oh I lost my t, 3t there. And so then we can divide by 3, e to the negative a half over 3 must be equal to t, and we can write that as 1 on 3 and then use our square root sign instead of our power of a half there. The negative takes it to the bottom and the square root sign for the half. So we get that our t is equal to 1 over 3 root e there. Now that we know that, we can then find the nature at that point. So we have our derivative. If we sub that back in to the second derivative, so our first derivative we used to find the stationary point, the second derivative we can use to find the nature. So we need to do the second derivative of this one here now. So our p double dash, our u is equal to 2 t. And so because our derivative of t is just 1, so we know that bit already. We're just focusing on this bit here using our product rule. So we've got our u is our 2t, our v is our ln 3t, so our u dash is equal to 2, our v is equal to 1 on t. Putting that together then, we have our 1, which came from our t there, and then we're adding to that when we do our product rule here, our u dash v plus v dash u. So we've got 1 plus, now our u dash v is going to be 2 ln 3t, and our v dash u is going to be 1 on t times 2t. Now when we do 1 on t times 2t, that's just going to give us 2 there, and we've got our 2 ln 3t there. So 1 plus 2 is 3, so we can write 3 plus 2 ln of 3t is our second derivative. Now that we've got that, we can now sub this value of t into there to check the nature of that one. So I'm now going to get that p double dash, and I'm going to put that 1 on 3 root e into there and find out what that's equal to. So I've got my 3 plus 2 ln 3t. So putting that in, I've got 3 lots of my 1 on 3 root e there, plus 2 ln of 3 lots of 1 on root 3, oh sorry, not 3 root e there. So here I've got, if I times by 3 there, I'm just left with my 1 on e. 1 on the square root of e, and then I am putting in my 1 over here, where I have 2 ln 3 lots of that. So here I've got 2 ln, and when I times that by 3, I've got 1 on the square root of e there. I can then make that 2 ln of e to the negative 1/2. And here I've got 1 on e to the 1/2 there, or e to the negative 1/2. And then, and I think I just added in, I've put a plus there and read it as a t. So I don't have this here. I'm going to come back to that original line and go from here. I've got 3 plus 2 ln 3t. So I just have my 3 there plus the 2 ln 3 lots of 1 on 3 root e. So then I've got my 3 plus my 2 ln of 1 on root e. Here that will become e to the negative 1/2. I can then bring down that negative 1/2 out the front, so that will become negative ln e. I know that ln e is equal to 1, so that's the same as having 3 plus negative 1, and that's 3 take away 1 is 2. That tells me then that my stationary point is a minimum. So I know if I've got a rough sketch, very, very rough here, I know that my 1 on 3 root e is my stationary point there. I know that this part here, it is increasing, and this part, is decreasing, and here it's increasing. So between 0 and 1 on 3 root e, I've got decreasing, and then on the other side it's increasing, and that was what we were trying to find there. So between 0 t and 1 on 3 root e, I can say that it is decreasing, and then on the other side it is increasing.